On this worksheet, everything to the left of column I is identical to what you saw before. We are still pricing 3% caplets, assuming a 30% vol. Column U shows the pricing of similar caplets, except that the strike has been increased to 3.01% from 3%. There is a reason for this, which you will come to appreciate very soon. Columns K and L are the most important columns in this worksheet. Column K provides the pricing of cap spreads. That is to say, the combination of being long the 3% cap and short the cap with a strike of 3.01%. Since this combination involves the purchase of the 3% cap and the sale of the 3.01% cap, the net premium paid by the investor would come to the difference between the first cap premium and the slightly cheaper second one. For example, if I purchase the 3% caplet for period 7, which starts in exactly 3 years, and I simultaneously sell the caplet struck at 3.01% for the same period, the net premium, being the difference between the two numbers highlighted in front of you, would come to only $2,333 as indicated in cell K15. My payoff at maturity is the most interesting feature of this combination. If LIBOR at the relevant time resets at or below 3%, both caplets expire out of the money and the investor receives nothing back from her investment. If LIBOR resets above 3.01%, the investor receives exactly $5,000, irrespective of how far above 3.01% LIBOR has reset. This is because the entire gain earned under the first cap is given back as a loss under the second cap, except for the 1 basis point that represents the difference between the two strikes. Applied to a notional of $100 million and a semi-annual tenor, this comes to $5,000. The more mathematical will reach the same result algebraically by noting that when LIBOR exceeds 3%, the payoff from this combination is equal to LIBOR minus 3% minus LIBOR minus 3.01%, which is exactly 1 basis point. Of course, we have left out the case in which LIBOR resets somewhere between 3% and 3.01%. And in that case, the net payoff received by the investor would vary between 0 and 1 basis point, i.e. $5,000, depending on exactly where LIBOR reset within this narrow range. We will ignore this subtlety going further and assume that within this narrow range, the payoff would also be $5,000. You should be able to recognize the all or nothing nature of the payoff we have just created. The investor at expiration receives either $5,000 if LIBOR has reset above the strike, or nothing. How far in the money she is at expiration is irrelevant. For this reason, this combination is referred to as a digital or binary caplet, since its payoff at maturity can take only one of two values, $5,000 in this particular instance, or 0. The graph of the payoff at expiration appears on this page and should make perfect sense to you. There is a very steep diagonal in the middle between 3% and 3.01%, which you will recall we are ignoring in our discussion and treating as if it's a perfectly vertical line to simplify the description of this product. In practice, the trader would hedge the risk that LIBOR might fall somewhere inside this very narrow range at expiration, and this would slightly increase the cost of the product. To illustrate further, we focus on the period beginning exactly 4 years from today, for which the net premium, which is shown in cell K17, comes to $2,493. Rounding our pricing to $2,500 for the sake of convenience, we are able to offer a very simple investment product to our customer. Invest today $2,500 and receive in 4 years' time, or to be more precise, at the end of the 6-month period starting in 4 years' time, an amount equal to $5,000 if LIBOR resets above 3%. In essence, the client can double her money if LIBOR, which currently stands at 2%, resets above 3% in 4 years' time. We can also multiply the notional of this trade by any amount we want to magnify the payout of this combination. If, for example, the investor prefers a payoff of $100,000, we would multiply the notional of this trade by a factor of 20. Of course, this would also drive up the net premium from $2,500 to $50,000, preserving the 2-for-1 payoff we encountered previously. Please note that from now on, we will refer to this combination as the purchase of a digital cap at 3%. But you should remember that we are purchasing one caplet and selling a second one. If conversely we say that we are selling a digital cap at 3%, you should interpret that to mean that we are selling a caplet at 3% and purchasing a caplet at 3.01%. Of course, we would in such a case be receiving the net upfront premium, since the option we have sold is more expensive than the one we have purchased. One very interesting property of digital caps, and generally of digital options for that matter, is their sensitivity to changes in volatility. Suppose you purchase the digital caplet for the period starting exactly 1 year from today. Your upfront premium would be $1,076. If vol were to rise immediately to 40%, you would naturally expect a gain, which is correct since the new price now for this combination comes to $1,231. So far, the digital caplet which we own appears to behave just like a regular call option in that it increases in value as volatility rises. Let's look, however, at row 17, which models the digital cap for the period starting in exactly 4 years. The initial price for this digital caplet, returning vol to 30% as before, begins at $2,493. Raising vol to 40%, we would presumably expect, once again, an increase in this net premium. But this is not the case, since the new price, in fact, has fallen to $2,112. To summarize, whereas for the 1-year digital caplet, an increase in vol resulted in an increase in the premium, which is normal, for the 4-year digital caplet, an increase in vol resulted in a decrease in the premium. You should now click the pause button and try to figure out why this is happening. It is not due to some error in the spreadsheet. The reason for the difference in outcome has to do with the different moneyness of the two digital options we considered. Note that the first digital for the period starting in 1 year was out of the money, since the LIBOR forward for that period is 2.5%, i.e. below the strike of 3%, while the second digital for the period starting in 4 years was in the money, since the relevant LIBOR forward for that period is 4%, i.e. above the strike. At this point, we remind any listener who has not completed our more introductory modules that for European options, we always define moneyness by reference to the difference between the strike and the forward rather than the spot. An intuitive explanation of what you saw above goes as follows. For the combination that begins out of the money on row 11, an increase in volatility increases the hope of collecting the $5,000 that await us at the end of the rainbow. This payoff being fixed, any increase in the probability of collecting it is beneficial and increases the value of our position. Turning to the combination that begins in the money on row 17, an increase in volatility cannot make us any richer, since our payoff is limited to $5,000, but would increase the probability of falling out of the money given the higher volatility of interest rates. We therefore have a fixed payoff whose probability of being collected diminishes when vol increases, causing our premium to decline in value. A more technical explanation based on the vega of different options with different moneyness will be provided in a later module for the more quantitatively inclined. We will conclude this module with a discussion in Chapter 3 of range-based structures, for which you will need to click on the worksheet labeled 3% to 4% range.